Right now, 1,400 light-years away, a star is disappearing. Not slowly. Not predictably. It's flickering, like something is blocking it. Something enormous. And the world's best astronomers cannot agree on what it is. By the end of this, you'll understand exactly what's happening to KIC 846-2852, the most bizarre star ever catalogued, why the explanations keep failing, and why one theory, the one scientists really don't want to say out loud, still hasn't been fully ruled out. In 2009, NASA launched the Kepler Space Telescope with one job: stare at 150,000 stars and don't blink. It was hunting for planets, tiny shadows that cross a star's face and dim its light by a fraction of a percent for a few hours. Predictable. Mathematical. Clean. But in 2015, a group of citizen scientists, ordinary people volunteering their free time through a project called Planet Hunters, flagged something that broke every pattern they'd ever seen. Star KIC 846-2852 was dimming by up to 22%. Not for a few hours. Sometimes for days. Sometimes weeks. And the dips weren't regular. They weren't symmetric. They were jagged, asymmetric, and completely unpredictable. To put that number in perspective, a Jupiter-sized planet, the largest kind of planet we know, blocks about 1% of a star's light when it passes in front. Whatever was blocking Tabby's star, because that's what they named it, after lead researcher Tabitha Boyajian, was blocking 22 times more light than a gas giant. No planet does that. Nothing we had ever seen does that. Scientists don't panic. They hypothesize. So the first explanation on the table was simple: a swarm of comets. A massive family of icy bodies, broken apart, orbiting the star in a chaotic cloud. That could block light unevenly. That could explain the strange dips. Except it couldn't. Not really. Comets release gas and dust when they're heated, and that dust should glow in infrared light. When astronomers pointed infrared telescopes at Tabby's star, there was almost nothing there. The comet hypothesis quietly collapsed. Then came the debris disk theory, maybe a young star surrounded by rings of planetary material, like a solar system still forming. Except Tabby's star isn't young. It's roughly the same age as our Sun. The material should be long gone. What about another star? A binary companion pulling material in strange orbits? Astronomers checked. No companion found. Instrumental error? A glitch in Kepler's data? Other researchers independently verified the signal. The dimming was real. And then, something even stranger surfaced. Astronomer Bradley Schaefer dug into century-old photographic plates, physical glass photographs of the sky taken between 1890 and 1989. He found that Tabby's star had been fading steadily for over 100 years. Not just flickering. Slowly, consistently, dimming over a century. Every natural explanation they tried left something unexplained. So here's where we are. A star that flickers in ways no planet, no comet, no natural structure can fully explain. A star that's been getting dimmer for 100 years. A signal so strange that serious, credentialed scientists published papers they knew would make them look ridiculous. But before we get to the theory that shook the astronomy world, you need to understand something about how we search for intelligent life. Because it changes everything about what comes next. In 1960, physicist Freeman Dyson proposed a thought experiment. If a civilization advanced enough wanted to capture every photon of energy from their star, they could build a structure around it. A shell. Or a swarm of giant solar collectors, wrapping their sun like a cage. We call it a Dyson sphere. And here's what a partial Dyson sphere, a swarm still under construction, would look like from 1,400 light-years away. It would block light. Unevenly. In massive, irregular chunks. It would cause the star's overall brightness to decrease over decades as more panels were added. And it would produce very little infrared signature, because an advanced civilization would be using that energy, not wasting it as heat. Check. Check. And check. Astronomer Jason Wright at Penn State was the first to formally publish the possibility. He was careful. He called it the least unlikely explanation, not the answer. But the word was out. Tabby's star fit the profile of an alien megastructure better than it fit anything else on the table. Since then, the scientific community has done what it does best. It kept looking. In 2018, a global telescope campaign confirmed something critical: the dimming is wavelength dependent. Blue light dims more than red light when the dips occur. That's the signature of fine dust particles, not solid structures. So the megastructure hypothesis took a hit. Solid panels wouldn't filter light by color. Dust would. The leading theory now is an unusual swarm of dust and debris, perhaps the remnants of a shattered planet or moon in an exotic, irregular orbit. It explains most of what we see. Most. Not all. The century-long dimming trend still doesn't have a clean answer. The sheer scale of the dips still pushes against every natural model. Tabby's star remains, officially unexplained. Here's what this star actually revealed, and it's more profound than aliens. We built a space telescope. We stared at 150,000 stars. And in that sea of light, we found just one, that we cannot explain. One star out of 150,000 that breaks our models, defies our categories, and forces us to confront the edge of human knowledge. That means the universe is stranger than our best theories. It means there are phenomena out there that we haven't even named yet. And it means that somewhere in the data we've already collected, there may be more. We didn't find proof of aliens at Tabby's star. But we found something almost as unsettling. We found the limit of what we know. And that limit is closer than we thought. Tabby's star is still being watched. Right now, telescopes around the world have it in their sights, logging every flicker, every dip, every fraction of a percent of change. Because if it dims again, dramatically, suddenly, we need to be ready to look closer than we ever have before. The universe doesn't give up its secrets easily. But every now and then, it leaves a light on. If this broke your brain a little, subscribe. We drop one of these every week. Next time, there's a void in space so large and so empty that it shouldn't exist by any law of physics we have. Scientists call it the cold spot. And some of them think it might be the bruise left behind from a collision with another universe.